Okay, we're in section 9.2, the unit circle and its functions. So we're going to introduce the unit circle. Hopefully this is at least a little bit familiar to you. It's called the unit circle because the radius is equal to 1, so 1 unit of whatever you're in, centimeters, inches, whatever. And if you remember back from when you learned about circles, you also know the equation of a circle. So you can see that here that we're centered at 0, 0. And we know that the radius is 1, so that gives us the equation of the circle, x squared plus y squared is equal to 1 squared, or just 1. So this is what we know for the unit circle. Alright, now we also know that the circumference is 2 pi, and we also know some of these points if we're sitting on the unit circle. So here would be the point 1, 0. Okay, just reading it off the graph like we normally would. This is the point 0, 1. This is the point negative 1, 0. Let me rewrite that one a little bit better. And then here is the point 0, negative 1. Okay, so that's a 0 there. Let's make that look a little bit better because we're going to use this for a few minutes. Okay, so 0, 1. Alright, so we know that these points lie on the circle because it's got radius 1. And then if we kind of tie this into the stuff that we were doing before as far as the arc length and the distance around and things like that. So remember, this was our starting point. This is our initial side. And this is also where our arc length is equal to 0, since it's our initial side. And then as we come around to here, we remember that that's pi over 2. And we come around to here and remember that that's pi. And we come over to here and remember this is, add another pi, we get 3 pi over 2. And then add another pi over 2, and we're back around here to 4 pi over 2, or 2 pi. Okay, so these things are equivalent. When we say pi over 2, that's the same as 0, 1 on the unit circle, and so on going around. Alright, now we're going to define functions on the unit circle. You may have, if you've done these functions before, you may have done them with a triangle. We're going to get to that later, so we're going to start with defining them on the unit circle. So as we go around the circle here, we've got various points, x, y. Okay, and we've given some specific ones as we go around with the zeros and ones, but there are infinitely many points coming around this circle that are the points x, y. So x is cosine of s, our arc length, and y is sine of s, our arc length. Okay, so those are our first trig functions, cosine and sine. And then we've got some other ones that are defined based on those. So we also have tangent. Okay, tangent of s is equal to y over x, or in other words, sine over cosine. And then we've got cosecant of s is going to be 1 over y, or in other words, 1 over sine. And we've got, let's see, secant of s. That's going to be 1 over x, 1 over cosine. And then we've got cotangent s. And that's going to be x over y, which would be cosine over sine. Okay, so this might look like a lot of craziness if you've never seen these before, but if you have seen them, at least in terms of triangles, it's the same definitions. Okay, it just looks a little bit different because we're talking about the unit circle instead. Alright, but the basis of all of this is that x is cosine and y is sine. Okay, and then the rest of this all comes from that. So tangent is sine over cosine. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. I remember that because the c and the s, okay, they're always opposite each other, s and c. And then cotangent is the reciprocal of tangent. So tangent and cotangent, look, they're just flipped. Okay, so there's the definition of all of our trig functions to get us started. Okay, coming back over here to our unit circle, I cleaned it up just a little bit. And we're going to keep this right here, the x squared plus y squared is equal to 1. We know that that's true for any circle of radius 1. So we see here, that works for the unit circle. Now if we add in this idea that x is cosine and y is sine, that means that this point can also be written as cosine s, sine s. Okay, so instead of x and y, we can write it as cosine sine. Now that means that our equation of the circle right here becomes cosine squared s plus sine squared s equals 1. Okay, so these two are equivalent statements. X squared plus y squared equals 1, and cosine squared plus sine squared is equal to 1. Now we usually write the exponent next to the function so that there's no confusion. We don't want this to look like cosine of s squared. So we usually put it next to the function. You could also write it, and this is how it would go into the calculator, as cosine of s squared like that. But just to save time and not put the parentheses around them every single time, we just go ahead and write it next to the function like that. Okay, now that rewriting the equation of the circle gives us our first trig identity. Anytime you have cosine squared plus sine squared, and whatever's on the inside is the same, you're going to get that equal to 1. Alright, now in terms of these being functions, x equals cosine s and y equals sine s, let's talk about the domain and the range. So we can, let me put the points back in here. We can see, let's put it in right, 1, 0, 0, 1, negative 1, and 0, negative 1. Okay, so if you remember back to, if you took college algebra or something similar, we can look at the domain in terms of the x values, and we can look at the range in terms of the y values. So when we're looking at cosine, cosine is x, and we see that the x's can range anywhere between negative 1 and positive 1. So we've got all these values here, all these values here. So x is between negative 1 and positive 1 inclusive, because it can actually touch them. So since x is the same as cosine, that means that cosine also falls between negative 1 and positive 1. Okay, and then same idea with our y's. So we can see that y's go between negative 1 and positive 1 this way. So negative 1 to positive 1 this way, and that means that sine also falls between negative 1 and positive 1. Okay, so let's take out this other stuff for a second. Okay, now kind of switching gears and ignoring the x's and y's that we had here, and let's just talk about cosine x, cosine s, and sine s. Oops, let me go back to brush. Okay, so looking at cosine of s, what kinds of things can we put in s? Remember, s is the arc length. So we can put in 0, 1, 2, 3, 4, 5, 6, 7. We can put in any of these numbers, and if we wanted to go past 2 pi, we would just keep going like this. Okay, so we can put in anything for s, and so that means that the domain is all reals. Okay, and then same thing for sine. We can put in anything for that arc length, and so the domain is all reals. Alright, now looking at the range, well, the range is what we just talked about right here. So what is the output for cosine? What's the biggest that cosine could possibly be? It's positive 1. And then the same thing for the smallest would be negative 1. So cosine, the output, whatever you put in for s, The biggest you're going to get is +1, and the smallest you're going to get is -1, and you get everything in between. So the range is going to be -1 to +1. And then the same thing here for this one. The range is -1 to +1. Okay, we're also going to talk about the domain and range of the other trig functions, tangent, cosecant, secant, and so on. I'm going to save that for class. As long as you understand this and you understand the basic ideas of domain from back in algebra, those should, for the most part, make sense, and we'll use them more later.